Hello, my name is Matthew Erickson. This is for the GAM470 class. We had assignment 1 where we had to do the star and the n-sided polygon. Take a look at the star first. I'll get this running while we move that off to the side. You can see it runs. Basically, I just used this given square program, made it a bit smaller, added the points for the edges of the triangles that we needed to add to the outside, and then added the winding triangle vertices that we needed to have here. And as you can see, it draws pretty much just like you would expect. The n-sided polygon, we can go up here and have it run quick so I can explain it while it's running. The vertices are going to be used with the cosine and sine. I found this function out on Google. It goes through, and for each vertice that you want, it'll find the information that we need. And then we come down here, and the number of verts, we have to make the actual points of each side of the triangle. This is where we're making the actual triangles. We're going to take the number of triangles we're going to need is the number of verts minus 2. We have to times the whole thing by 3 because each triangle has 3 points. Each triangle is going to start at 0, and then it's going to be the j, which is at the end, is going to be added. So the j is just the number of the triangle, like the first triangle, the second triangle, and that's how it's going to wind around. That was running with 12 vertices, and we can run it with 25 just to show that changing that value does work. While this is coming up, we can, there it is. As you can see, it runs just fine. So now we can take a look at the further work that we had to talk about. This one's talking about changing the z values of the points. This happens because our buffer only goes from 0 to 1 in the z. So if you change a value outside of 0 to 1, let's say 2, that would be outside, so it wouldn't get drawn. And because it's far enough outside, that part of that edge, about half of that edge that you would create between it and one that's inside of it, is going to be outside of the 0 to 1. You're only going to be expecting about half of that edge to show up. This is why the trapezoid shape shows up. And then also why when you move the lower right vertex out in the z, that it makes it into a small triangle on the left. It's not really a strange behavior. It's actually expected based on the fact that most of the triangle at this point is now trying to be drawn outside of the z buffer. At the end of the init, we have various options for the viewport. Changing the top left will actually allow you to draw smaller than the full window, which is very convenient for UI features. Adding in UI, if this browser was our game, this top part, would be our UI that we need. And then, so we'd want the, the viewport to start at about here. So that's why that would be useful. Also, there is the ability to draw more than one viewport, which comes into, which would be very useful for split screen multiplayer or VR. The last part is the DXGI formats, the RGBA versus the and just the R. The RGBA is the red, green, blue alpha, and the 8 stands for 8 bits. So each, the red, the green, the blue, and the alpha will have 8 bits worth of information. The U norm means that you're going to be unsigned norm, normalized being 0 to 1. Unsigned means that it's positive. The U int in the R16 U int means unsigned integer, which is once again based on the bits that is used in the information. Here it's 16 bits, so it's going to be 2 to the 16th, so it'll go from 0 to 2 to the 16th minus 1. The signed integer, or the SInt, it stands for signed integer, will allow you to have negative values. Basically, it's going to go from 2 to the n divided by 2 in the negative area to 2 to the n divided by 2 minus 1 in the positive. And then the R16 is useful for storing depth buffer. It's useful for that. So basically where these pixels are at in the Z, basically you're just storing the Z coordinate of where these pixels are at. Thank you. And that is